All right. Morning. Good morning. Good morning. Good morning. So, guys, we are just continuing the episode of functions. We've looked at all the different types of functions: straight line, parabola, hyperbola, exponential, and basically all the functions. We've looked at the basics: what is the form of each function, how to sketch each function, how to find the equation of each function. So we've been doing that. Now it's time to look at the different transformations that we find in functions. And specifically, we're going to look at your reflections and your translations for each respective function. So this is relevant for grade 11 and grade 12. So if you are a grade 11 learner or you are a grade 12 learner, then this is good for you, so that we can be able to look at what effect does the reflection have on a function depending on where we are reflecting. And then of course translation being whether we are talking about vertical translation or horizontal translation. So let's go and look at each of these. So here, what type of function is this? Can you guys tell me what type of function is this? Let's just check if you guys have an awareness of the type of function. This one, what type of function is this? What do we call this function? The first one. Maybe Tupsy, do you know what type of function this is? In fact, anyone who would dare to answer? Yes, Billy, we call this a hyperbola function. Very good. What type of function do we refer to this as? So yes, this one is a hyperbola. It's got that form: y is equal to a over x plus q, x plus p plus q. It has that form. What about this one? What type of function is this? The second one. Yes, Billy B, we refer to this as an exponential function. Very good. It has that form: ab to the power x plus p is an exponent plus q. All right. Then what type of function is this? Okay, Billy V is on a roll. Quadratic. Very good. All right, it's got that form: ax squared plus bx plus c. All right, very, very beautiful. Okay, this here is relevant for grade 11 and 12. Okay, okay, let's come down. Right, now they say the graph of g of x is obtained. Now remember, we are initially talking about f of x. Now all of a sudden we are mentioning g of x. Now remember, g of x is obviously going to be a new function. Now they are saying the new function g of x is obtained by what? By shifting the graph of f of x 2 units up and 3 units to the left. The question is, if we take f, which is this function, and then do this, shift it 2 units up and 3 units to the left, what does 2 units up affect? Does it affect our p value here, or does it affect our q value here? If we're saying 2 units up, what does this 2 units up affect? Is p going to be affected, meaning the plus 1, is it going to be affected, or is it going to be the q value that is going to be affected? If we are saying the graph of g is a new function, we've established that g of x is a new function. We are told it is obtained by shifting the graph of f of x 2 units up. So by 2 units up, who is affected? Yes, na pokati, it is -3 that is going to be affected. And yes, believe q is going to be affected. So let us then say, if g of x is a new function, and we are saying it is affecting a f of x, that means we are going to have 2 over, now let's leave this plus 1 for now, -3, 2 2 units up, if we say 2 units up, that means that affects the Q value, meaning the -3. So we are going to say +2. +2, because 2 units up means we add to the Q value. Very good. Okay, we add, so Q is affected. All right, very good, Billy V. That means our Q value, our new Q value is going to be -1. Okay, let's leave that one. Then when we say 3 units to the left, what does that mean? Who is affected by 3 units to the left? Remember, up means we are, this is basically speaking about our vertical translation. Vertical meaning up or down. Up, we add. Down, we subtract. Up, we add. Down, we subtract. Then, if we are saying 3 units to the left, what does that mean? 3 units to the left means we do what? Who is affected? Is it P or Q? This time round, we are not talking about a vertical translation. Rather, left means a horizontal translation. So that means if we are saying 3 units to the left means we add 3. 3 units to left. Okay, to the left means we add. To right means we subtract. That's why we say this here is counterintuitive. Our horizontal translation for this particular p-value, if we are saying to the left, we would naturally think that to the left means minus, but it is actually counter. The word counter means against. It's a prefix in English that means against. Intuitive means thought or thinking. So it's against our natural thought of thinking. 3 units to the left, we would naturally think we are meaning minus, means actually to add. Counterintuitive. To the right means subtract. Counterintuitive. I hope you understand this notion. So when we're saying 3 units to the left, we are not going to subtract from P, rather we are going to add to P. This is very, very important, and I'm going to put this in a circle because this is very important. Okay, I hope we are together here. So that means the g of x, the new function, is actually going to be 2 over x plus 4 minus 1. This is the new function, guys. If we apply the translation of 2 units up, we add, because up we add, up we add, up we add, down we subtract, up we add. 2 units up means we add to the Q. Left means we add as well. It doesn't mean we subtract as we would naturally think. It's counterintuitive. It's against our natural frame of thought. So therefore the P, the effect that it has on P is that it's counterintuitive. So we add 3. So therefore that's going to be x plus 4 as our expression in the denominator, minus 1 as our constant term. Okay, are we together, guys? So this is the new function g of x. Very, very important. Very, very important. Okay, any questions, guys? Any particular questions? So thought about very well. If we write it in functional notation form, it means f of x into x plus 3 plus 2. This is basically the functional notation if we are to actually say what is the explanation. The graph of g of x, meaning g of x, is obtained by shifting the graph of f of x 2 units up. That means we add to the q value, and 3 units to the left, meaning we add to the p value as well. That's why you see plus 3 there for f of x, and that's why you see plus 2 there as well. And the effect leads us to a function of g of x, which is 2 over x plus 4 minus 1. Let me repeat this one more time. So we are looking at the f of x. This is saying the graph of g of x is obtained by shifting the graph of f of x. G of x, new function. How is it obtained? The new function is obtained by shifting the graph of f. Where is f of x? Here is f of x. 2 units up. What does 2 units up? 2 units up speaks to what we call vertical translation. The word vertical means up or down. Up or down. When we say up, it means the parameter that is affected is q. So that means we are going to add 2 units up. We are going to add 2. We add 2 to q for f of x. That's 2 units up. If it had said 2 units down, we were going to subtract from the q value. Okay. Then when it says 3 units to the left, that means the parameter that is affected is going to be our p. The expression in the denominator is affected. Okay. Therefore, that means if we say 3 units to the left, to the left, to the left, to the left means we add, because the p parameter is counterintuitive. In your natural frame of thought, you think to the left means what? It means minus, but it doesn't mean that. It means we add to p. So therefore we add 3 units to the p value. So that's why we say 3 units to the left means plus 3 to p. So plus 3 to p, 1 plus 3 is 4. Therefore, our function of g of x, the new function, is truly obtained. It's g of x is equal to 2 over x plus 4 minus 1. I hope we are together there. Okay, let's move on to this function, the exponential. So the hyperbola function, we understand how translation affects our function. Up, we add to q. Down, we subtract from q. Left, we add to p. To the right, we subtract from p. Let's never forget that. Let's move on to another function. The p and the q value, or let me say the translation, vertical and horizontal, is the same for all of the functions. Let's look at this one. We are told here the graph of g of x. What is g of x? G of x is a new function. How is the graph of g of x obtained? The graph of g of x is obtained by shifting the graph of who? Of f of x. There's f of x. 2 units up and 3 units to the left. What does that mean? 2 units up. Up means we affect which parameter? Okay, it doesn't change, guys. Up means we affect the q value, meaning we affect the plus 4. Okay, so that means we are going to 2 units up means plus that 4. Very good, Billy, which means we are going to add 3 to 4. 3 units to the left. To the left means we affect which parameter? The parameter of p. P is the exponential expression there, negative 2. So that means 3 units to the left, we do what, guys, to the p value? We are going to do what? What did we say? What did we establish from the previous function? To the left means we, to the left, 3 units to the left means we add 3, okay, to p. So again, this is g of x is obtained by f of x plus 3 plus 2. So if we write down g of x now, we say 2 times the 3x minus 2, we add 3 plus 2, we add, plus 4, we add 2. Okay, so we add 2 units to q, and then we add 3 units to p. So then our function of g of x will be 2 times 3 to the power minus 2 plus 3 is x plus 1 plus 6. This is the new function at g of x. It is 2 times 3 to the power x plus 1 plus 6. Remember, you cannot multiply this 2 and this 3 because BODMAS does not allow it. You leave your exponential function as in that form. Okay, any questions, guys, so far? Are we following nicely? So vertical translation, up or down. If you are saying up, you are adding. If you're saying down, you are subtracting. To who? To q. If you are moving left, you are adding. If you are moving right, you are subtracting. To what? To p. Okay, and that is the same thing you do for all of the functions, whether it's a hyperbola, exponential. Let's go to your parabola now. Let's go to our parabola. The parabola f of x is equal to x squared plus 5x plus 6. The graph of g of x is obtained by shifting the graph of f 2 units down and 3 units to the right. Determine the equation of g of x. Now, this function is in the form whereby we can't see p and we can't see q. But we can first get this function to be in the form where we can see p and where we can see q. So if the function is in this form, how do we convert this function so that it is in the form that we need or require, so that we can be able to see when we are shifting the graph 2 units down and 3 units to the left? How do we basically make sure that we get our function to be in that form? Okay, that is the $1 million question that we have for ourselves. Okay, now you see, what did they say here? 2 units down and 3 units to the right. So this one is a bit different. 2 units down. So when they say 2 units down, what does that mean? We have f g of x is obtained, in other words, by doing what? What does 2 units down mean? Okay, 2 units down means what we do what to q? We are going to minus 2 from q. We do what to 3 units to the right? That means we are going to subtract from the p. Currently, our function is not in that form of the function that we want. Okay, but anyways, something to note, guys, is that this x minus 3, when the function is this form, you can actually do this as well. You can say g of x is equal to, look, if we take x minus 3, we substitute it where x is. It's doable, guys. Okay, I think sometimes we tend to make life very difficult for ourselves, but it's doable. Okay, look at this. Let's first look at this. Okay, so that you can see that we can actually get the function in this form. Okay, I just want to show you guys, look. So that is, we square the first term, we square the last term, we multiply these two, and then we times by 2, so that's negative 6x plus 5x minus 15 plus 6. You add the like terms here. This is one way of doing it. I'm just showing you guys the different ways. Negative x, 9 plus 6 is 15, 9 plus 6 is 15. Then 15 minus 15 is 0. So you're left with g of x is equal to x squared minus 2. Then you subtract the 2. Remember, you subtract 2. Okay, yeah. So therefore g of x, because you come now, you input this part. That is actually going to give you x squared minus x minus 2. That is g of x. That's one way of doing it. Okay, yeah. This is one way of doing it. Okay, one way of doing it. Or someone else could basically go ahead in grade 11. You really remember, you complete the square. Remember how to complete the square of an expression? Okay. Yeah, me, I'm just exposing you guys to various ways. You could complete the square of the expression of this form, because the way in grade 11 that you learned you can change this form to be in the other form is by completing the square of the expression. So what do you do? So let's say first, let's just take this function as it is and complete the square of the expression. How do we complete the square? First and foremost, we take out the common factor, which in this case is 1. Then, okay, the x squared plus 5x, what you do is you say x squared plus 5x. You add what? 5 over 2. And then what do? You square it. You do the same thing, minus 5 over 2. You square it. So remember, what we do is we add the coefficient of the middle term, which is 5. Then we multiply it by half, and then we square it. That is basically the rule when you complete the square of an expression. Plus the 6, of course. That's 6. So you add this and you subtract the same thing. Okay. Then what does this do? This is what this does. You are then left with x squared. Now check very quickly what we get. X squared plus 5x plus 5 over 2, the whole thing squared. But remember that this here is a trinomial expression, and it's a perfect square trinomial. So the way in which you are able to factorize this is you say x plus 5, the whole thing squared. This x plus 5, the whole thing squared, will give you back this. You take x, you put him down here, you took 5 over 2, you put him down there. This is how we factorize this trinomial. It's x plus 5, the whole thing, x plus 5 over 2, the whole thing squared. Then you come here. What's 5 squared? 25. What's 2 squared? 4. Plus who? Plus 6. Okay. Then you get x plus 5 over 2, the whole thing squared. Okay. Minus, then you can add here, negative 25 over 4 plus 6. If you add this, you can take your calculator even, but obviously, like if you do it manually, LCD is 4. So obviously, if the LCD is 4, it means the denominator has to be 4. The quick and easy method is to multiply the 4 and the 6. So you have 25, negative 25 plus 24. Then you multiply the 4 and the 1, which is 4. 4 times 6, 24. 1 times 5, negative 25, with the 25 there, over 4. X plus 5 over 2, the whole thing squared, minus, what's negative 25 plus 4? It's negative 1 over 4. Okay, so this is the completed square expression. Okay. Then we apply what they said, which was what? 2 units down, 3 units to the left. 2 units down. So we come here, x plus 5 over 2. 2 units down means we subtract 2. No. Sorry. This is not applicable. 2 units down. Remember, 2 units down applies to q. See, now we are forgetting. We're saying 2 units down. Who are we affecting? Q. If we're saying, so that's minus 2. If we're saying 3 units to the right, that means we are doing what? We are subtracting from the p-value. So let's do that. X plus 5 over 2 minus 3 minus 1 over 4 minus 2. Okay, then now you must do the maths here. So here we have x plus, actually it's going to be x minus 5 over 2 minus 3. Okay, you can take your calculator and say 5 over 2 minus 3. What's 5 over 2 minus 3? You get negative 6. 5 over 2. So you're going to get negative 1 over 2. Minus negative 1 over 4 minus 2. You are going to get negative 9 over 4. I believe. Okay. Yeah, I think this is basically how we would go about it. Okay. This was f of x, but now when we apply, this is in our g of x. Yeah. So this is the function for of g of x if we have the function in this form. And I think if we were to simplify it, the question is, would we get the function that we had initially got here? We're going to see if that will be possible. Let's expand this and see if we will still get that function form, because we want to confirm if this method is still relevant. Let's see. Let's do it. So we square the first term, we get x squared. We square the last term, we get positive 1 over 4. We multiply these two, x times the negative half x, that gives us negative half x. We double it, we get negative x. Then minus 9 over 4. When we expand it, this is x squared minus x. What's 1 over 4 minus 9 over 4? The denominators are the same, so we add the numerator and subtract them. 1 minus 9 is going to be negative 8 over 4. Oh, we get the same function, so it works. So g of x actually is equal to x squared minus x. What's negative 8 divided by 4? That's negative 2. So do you see, even this method works, guys. It works out nicely because the same g of x that we got, which is x squared minus x minus 2, is the same g of x that we are getting here, which is x squared minus x minus 2. So the scale of completing the square of an expression is a skill that needs not to be outdated. We need to be able to apply it as well if the need arises. Okay, so different ways of getting to the same answer, okay, as we apply our translation. Let's just reflect again what the question asked. I'm sure you guys can think of another method besides the two that I've actually indicated in the comment section. So I mean, in the examples above, the graph of g of x is obtained by shifting the graph of what? Of f of x 2 units. 2 units where? 2 units down. So 2 units down means we subtract from q, where our f of x is concerned. Then 3 units to the right means we subtract from the p. Okay, so this method that I've just done now, this one, required me first to take the function and then complete the square of the function, the expression. How? First, you take out the common factor, which is 1. Then afterwards, you rewrite x squared plus the 5x. Then your focus is here. You add the coefficient, which is positive 5, which you then divide by 2, or you multiply by half, which is the same thing. Then you square it. But what you add, you also subtract the same, so that the square can be completed. And then you add the 6, which is basically the constant that was there. When you factorize, you are supposed to then factorize the perfect square trinomial x squared plus 5x plus 5 over 2. The simple basic way of doing that is you take that x, you take the 5 over 2 in the brackets, and then you simply put a bracket around it and you square it. This here, when you multiply out, gives you back this perfect square trinomial. So this is a simple way of basically factorizing the perfect square trinomial. You always take that, put it there, take what's inside this bracket, put it there, you put a bracket and you square everything. This would give you back this if you were to multiply it out. Minus what? Minus the 5 squared, which is 25. If you apply the square to the 2, it's 4, plus the 6. You add this together, you get negative 1 over 4. So this is completed. The square of the expression is completed. Then, when we apply the transformation, remember, what did the transformation say? It said, when f of x is done what to it to obtain g of x? 2 units down. It's shifted. F of x is shifted 2 units down. That means we are going to do what to the p-value? We subtract 3 if we are moving 3 units to the what? To the right. Then we subtract 2 from q if we are moving 2 units down. Okay, then guys, we can take our calculator, add 5 over 2 minus 3 gives us negative half. Negative 1 over 4 minus 2 gives us negative 9 over 4. And we can see this is the new function of g of x. If they say leave the function in this form, there you have it. But if they say leave the function in your standard quadratic form, then you can expand this. Square, square, multiply, double, you get negative x. Minus the 9 over 4, you add your like terms, you get g of x, which is x squared minus x minus 2. So it works out, guys. This truly is the function. One way of doing it here, another way you could have done it above as well, where here we explicitly took the x, we substituted x minus 3, then we subtracted 2 at the end so that we can get the function of g of x. We can see this is the same as that one there. So it works out very nicely. So guys, I hope we are on the clear about translation as it relates to vertical and as it relates to horizontal. So in summary, we are saying for vertical translation, up we add to q, down we subtract from q. That is, like, in summary what we are doing. That's vertical translation. Horizontal translation, if we are moving to the left, that means we are doing what to p. To the right means we are doing what to p. To the left, what do we do, guys? Are we adding or subtracting to p if we are moving to the left for horizontal translation? To the left means what? Thank you, Cicely. To the left, we add to p. Remember, we said this is counterintuitive, meaning it's against your natural grain of thought. Yeah, so we must not forget, guys. If we're saying to the left, when you think to the right, to the left means subtract, but then we are adding, guys. It's against, counterintuitive. Horizontal translation is counterintuitive for the p value. To the right means we subtract from p. Okay, if we've got that down, then I vertical and horizontal translation. So this is for all functions, whether it be your parabola, hyperbola, or your exponential. Okay, don't ever forget that. So if you learned anything from me that you did not grasp before, it's this, that vertical translation, up or down movement, you add to Q if you are going up, you subtract from Q if you are going down. Horizontal translation is counterintuitive, so to the left means add to P, to the right means subtract from P. Don't ever forget that for your own sanity. Okay, let's move on. We've looked at translation and it makes sense. Now let's look at some other concept which we refer to as reflection. Let's go down now. We're going to look at reflection. We're going to look at what? Reflection. Now let's go down here. B, the graph of H. Now H is a new function. They are saying the graph of H is obtained. How is the graph of H obtained? Okay, let's hide this so that we can zoom in and focus. The graph of H is obtained by reflecting the graph of f of x in the x-axis. The graph of H is obtained by reflecting the graph of who? Of f of x in the what? In the x-axis. So let's remind ourselves, what's the graph of f again? The graph of x of f, remember, is 2 over x plus 1 minus 3. So we are saying, what are we saying here? We are saying the graph of H. H, what is H? Is H mentioned anywhere? No, it's a new function. Guys, always remember, when they say these things, the graph of H of x, it's a new function, that one. You did not see it above anyway. So now they are talking about a new function. The graph of H of x is obtained by reflecting the graph of f of x in the x-axis. So when you need to first understand, what does reflection in the x-axis mean for the function? We need the meaning. Okay, so on your Cartesian plane, you have what we call the y-axis and then the x-axis. So the x-axis is here, right? So if I have something here, all right, and then I reflect it on the other side. Let's say this thing was at y is 3 and x, maybe let's say is 2. Let's say I reflect the point A. Let's say this was the point A, 2 and 3. And then I reflect it along. This is the x-axis. So if you reflect something in the x-axis, you can see that this would basically form, the A now would form on the other side. But take note what would happen. What stays the same here as you reflect in the x-axis? The x value will still be the same. The y value, there are two things about reflection. The distance from where you are reflecting, from here to there, the distance from here to here is the same distance from where you are reflecting to the other point. So there is this concept of equidistance when you are reflecting. This concept of what, guys? The word equidistant. So your distance from the point where you are reflecting, imagine that the x-axis was like your mirror. It's like, guys, if let's just say, let's think about it, this thing. If you are standing and you are looking at a mirror, let's say you are standing here, you are looking at the mirror, here's the mirror. If let's say you were someone who could, maybe you were living in the witchcraft era and you could jump into the mirror and then from the mirror walk the distance from the mirror to where you are seeing your reflection. The distance from the mirror to your reflection is the same distance from the mirror to where you are standing. Okay, I need you guys to comment in the comment section to say you understand what I mean. I'm saying if we're living in the witchcraft era, you know, I mean, you sometimes watch those movies where you are seeing someone jump into the mirror and they can actually walk to the other side of the mirror. Does that make sense? So that's a reflection. It's a mirror reflection of the person standing. So if, let's say this is A, if we are reflecting, if I say we are reflecting in the x-axis or along the x-axis, sometimes they hide this thing and they say reflecting in the line y is equal to 0. All of this means the same thing. Reflection in the x-axis, reflection in the line y is equal to 0. Remember, the equation of the x-axis is y is equal to 0. So you need to understand all the language that can mean reflecting in the x-axis. They can say reflection in the x-axis, reflection along the x-axis, reflection about the x-axis, along, in, about, on. That's all reflection in the x-axis. Or they can say reflection in the line y is equal to 0, when you must remember that the x-axis has an equation. It's y is equal to 0. So if you are reflecting in such a way, your x value stays the same. Y, what happens to y? The only thing that happens to your y value, guys, is that the y value changes sign. That's all. So this A reflected along the x-axis, your x value stays the same. Y changes sign. That's all. That's what a reflection in the x-axis means. X stays the same. Y changes its sign. So guys, please, man, don't be baffled when you are asked to write the equation of a function when they are saying it's reflected in the x-axis. All that means is that your y is changing. Y is changing. Y is changing its sign whilst x stays the same. If that's what reflection in the x-axis means, then if we look at another concept, what about reflection in the y-axis? Okay, so let's say we had B here. B is 2 and 3. We reflect, and let's say we have B that has changed. This time round, who is staying the same? Who is changing? I'm sure you can understand. We are reflecting in the y-axis. That means the distance from here to there is the same distance from here to there. Okay, so 2 units in distance. But now, who stays the same on the horizontal? Okay, so if we're reflecting, and I need you to understand the language, reflecting in the y-axis, or we can say reflection along the line x is equal to 0, because the y-axis has an equation, x is equal to 0. So if they say reflection in the y-axis, most of you will know what that means, but some of you tend to not know when they say reflection in the line x is equal to 0. Guys, the line x is equal to 0 is the y-axis. So please understand the language, whatever they say. So if we're reflecting along the y-axis, what is happening this time? Y value stays the same. X will change the sign. Same number, different sign. Okay. Are you feeling me there? Vivi, I could see you're the only one that's basically like commenting in the comment section. But is everybody else like, there's a supposedly 129 people that I hear, you know, but you never know. Ivile, I can see when you are saying Uvile. I think Uvivi is following her name. Uvile, okanye his name. Cicely, thank you. Parnas. Is it Cicely Parnas? Billy V is not my girl. Is it Billy G? Billy G. Victoria Dewoho is like, you're a good teacher. Thank you so much. It's appreciated. Okay, appreciate the kindness in words, fellow colleague. I believe you're a fellow colleague because I can see you in black there, Victoria Debo. You know, very, what you might call, professionally dressed there in that profile picture. Umuhle. Cecily, thank you. Okay, so we understand. Okay, so now I'm going to go to the function now. Okay, so you understand it for the coordinates, all right? We practically understand what reflection means. So practically then, if they say the graph of h of x is obtained by reflecting the graph of f of x in the y-axis, in the x-axis, determine the equation of h of x, where now you are saying h of x is equal to the negative of f of x. That's what it means functionally. Why? Reflection in the x-axis, we've all said reflection in the x-axis means the x value stays the same, y changes. So remember, f of x, what does f of x mean? Means y. So now what I'm saying is that the new function is established or found by, obviously, we are going to say negative multiplied by the positive y value, because that's a reflection in the x-axis. Then there is f of x. How many terms does f of x have? It has 1, 2 terms. So that means our negative is going to be written there outside. Now we're going to distribute the negative to the 2 terms. What do we get? Negative 2 over x plus 1 plus 3. That is the function h of x when we are reflecting the function of f of x in the x-axis. This is what it means. The y value changes, yx stays the same. So that is why we multiply the positive f of x with negative, because we are applying the notion that the y value is changing. Then you substitute f of x, which is the 2-term expression, you put it in brackets, you distribute the negative sign. The final answer is negative 2 over x plus 1 plus 3. This is the function of h of x when f of x is reflected in the x-axis. Are we together, guys? A reflection in the x-axis can be applied to our equation in such a fashion. Billie Jean is not my girl. Yeah. Okay, are we good, guys, with the function? All right. Yeah, this is just a nice recap for all of y'all. Yeah, because this recap is very important. We need to be masters now. Masters of the master, you know, masters of the master. Okay, they should come and say you are master function. The graph of h of x is obtained by reflecting the graph of f of x in the x-axis. Determine the equation of h of x. So now we are moving from the hyperbola to the exponential function. What was the exponential function? Got the f of x. We knew that the exponential function f of x is 2 times 3 to the power x minus 2 plus 4. Thank you so much, Hayam, for humans. Thank you so much for the 3 roses. Much appreciated. You are too kind. Come on, the roses. Thank you so much. Really appreciated. You too kind for the humans of themselves. Okay, f of x. So here we are saying the graph of h of x is obtained by reflecting the graph of f of x, meaning our exponential function here, which is f of x, in the x-axis. Determine the equation of h of x. So once again, h of x is a new function. Reflecting in the x-axis means what? We established that reflecting in the x-axis means what? The x value stays the same whilst the y changes sign. So h of x is equal to negative for our exponential function. In functional notation, we change f of x, which is positive, to negative, because remember f of x means y. Then that means our function of h of x is equal to the negative sign put outside the two terms. How many terms does the function contain? It has 1 plus 2 terms. So we say negative into 2 times 3 to the power x minus 2 plus 4. Then we play the distribution game. We take the negative inside the bracket to the first term, negative to the second term inside the bracket. So a negative times this gives us a negative 2 times 3 to the power x minus 2 for the first term. That changes from positive to negative. And then, of course, a negative times a positive gives us a negative 4. Thank you very much. So then our function of h of x is equal to negative 2 times 3 to the power x minus 2 minus 4. Very true, Nessie.com. No crying emojis. Rather, thank you so much, AM for Humans. You are so kind with them gifts in the comment section. You are too kind. I really appreciate you too much. The first sign of love received this morning. Actually, not the first sign. Yes, there's been positive comments. I really appreciate them. But me, I'm a sucker. My love language, gifts. Thank you so much. Really appreciated. AM for Humans. I think AM for Humans is all about humans there, guys. Physician, clinical hematology, fellow making medicine, makes sense, public health, education for everyone, where blood science meets real life. I think someone worth following, definitely. Physician and clinical. Yeah. Thank you so much. You are too kind. Very generous. I'm very appreciative of that. Okay, so guys, you can see reflection in the x-axis applied to the hyperbola function for the equation. You can see, guys, the direct application of it. Reflection in the x-axis applied to the exponential function. Guys, you can see the direct application of it. Okay, changing of y, and then the distribution to the two terms of the expression, two terms of the expression. Now let's look at the parabola. Remember our parabola function, we are saying the graph of h of x is obtained by reflecting the graph of f in the x-axis. So once again, we first listen to the question in the x-axis. What does that mean? It means y changes whilst x stays the same. We've come to understand that now very well. So the graph of h of x, first and foremost, what is f of x for the parabola? We're given x squared plus 5x plus 6. That is f of x. Now we are supposed to do what? Reflect the graph of f of x in the x-axis. So we need to determine the equation of h of x. So functionally, according to your functional notation, h of x is equal to negative of f of x, right? Then here we are. This is f of x. So h of x, we now substitute in the place of f of x, x squared plus 5x plus 6 in brackets. Why in brackets? Because the negative sign must be applied to all the terms of the function, the expression function. So we need to then showcase that. How many terms? 3. We distribute the negative sign to all 3 terms. What's a negative times a positive? We get negative x squared. Negative times positive 5x, we get negative 5x. Negative times a positive, we get negative 6. So therefore our function of h of x, ed negative x squared minus 5x minus 6. So this is just how we look at reflection in the x-axis. Guys, if there's reflection in the x-axis, surely there is also reflection in what axis? In the y-axis. So we are going to look at that to basically also conclude our reflection types, so that we also have a clear understanding of reflection in the y-axis. So once again, look at the question as then stated here. The question says the graph of f of x is obtained, the graph, of m of x. So we are talking about a new function here. A function never before seen. But how is it obtained? It's obtained by reflecting the graph of f of x, how? In the y-axis. So once again, we listen to the language in the y-axis. What does that mean? So practically speaking, you remember when we looked at the practical example of reflection in the y-axis, you remember when we looked at the point on the Cartesian plane, We looked at point B and we said if point B is 2 and 3 and we reflect that point along the y-axis, what does that mean? Okay, the distance from the axis where you are reflecting will be the same, right, on either side of the particular x-axis, the particular y-axis that you are talking about. So our distance from here to there will be the same distance from here to there on the same horizontal line. Therefore, who stays the same? Our y value is still going to be 3, meaning y does not change, but rather who changes when we reflect in the x-axis? It is x. The sign of x changes. So y values stay the same, or our y stays the same whilst x changes its sign. So now that I'm going to look at examples that pertain to the equation of f of x for each function, let's first look at the hyperbola. Remember, hyperbola of f of x was f of x is equal to 2 over x plus 1 minus 3. So when they say reflection in the y-axis, remember they could also say reflection along the line x is equal to 0, because the y-axis is also the line x is equal to 0. So we must know both language, okay, both the language of reflection in the y-axis and reflection along the line x is equal to 0, because the y-axis has an equation. The equation of the y-axis is x is equal to 0. So you must take note of both language, reflection in the y-axis or reflection along the line x is equal to 0. Make sense? So therefore, what does that mean? When we're reflecting in the line the y-axis, we saw who stays the same, we saw who changes. So here it is. We say m of x is equal to f of negative x. Why are we saying m of x is equal to f of negative x? This time round, we are not saying negative of f of x for reflection in the y-axis. Rather, since we understand it's x that changes the sign, the x needs to change the sign. Okay, we apply a change in the sign to x alone. So let's go ahead and do that then. That means m of x is equal to 2 over, in the place of x, we now write negative x plus who? Plus 1 minus 3. But we don't stop there, guys. Thank you so much, Ndori, for the support of the work. Okay, that change of x is negative x, right? Because we are talking about a reflection where in the y-axis, that means who stays the same? Y stays the same. Who changes? X changes. So therefore we change x to negative x, but we cannot leave our denominator having a x variable that is negative. That is not how we leave our answer for the function. So then we are going to employ our factorization concept or our factorization skills. How? In the denominator, we are going to look at the expression in the denominator and take out the highest common factor. Now, highest common factor, when we take out the highest common factor, and I usually say this to my learners, if you are factorizing, guys, there is these 3 letters here. Usually see them in the movies, SNL, you know, they mean something very hot and happening when you are watching a movie. You dare not watch such movies. Young people, I usually encourage, don't watch such. When you see these letters when you are about to watch a movie, it's a good sign that you need to switch off the TV and do some maths. The S means sign, N means number, L means letter. So you take out the highest common factor sign first. What is the highest common factor sign? It's the sign of the given first term in the expression. So here we can take out a negative. We then move on to the number. We take out the highest common factor number. Between, there's a 1 here that you don't see. It's invisible. And there's a 1 there. You take out the highest common factor number. It's 1 as well. Then letter, if there is 1, we usually say we take out the common letter with the lowest exponent. Okay, we usually say we take out the highest, the common letter with the lowest exponent. But we have no letter here that is common. So you are going to take out a -1. Then what are we left with inside? When you take out a negative, all the terms in the expression inside, they change sign. So we are going to have x minus 1. Are we together, guys? Hey, I hope we are together here. Then this 2 divided by this outside negative, positive divided by a negative gives us a what? A -2. Then in the denominator, we are safe. We just have x minus 1. We have avoided having a x that has a negative sign in the denominator. So we have escaped that monster, and therefore our m of x, guys, is now given as a function with no denominator of x having a negative sign. This is something we need to make sure that we do. Okay, so yeah, guys, same the movies, but here we know that S means sign, N means number, L means letter. We are trying to purify and restore morals so that our learners can then now be driven to things that will build and help them in their pursuit of these critical gatekeeping careers, if you want. It's gatekeeping subjects that basically are the gateway to important careers like HAM for humans. Thank you so much, HAM. The claps, I really appreciate it. You are so appreciated this morning. You've come here as a bearer of good gifts, and I appreciate it. Thank you so much. You are appreciated. I appreciate gifters, because unfortunately or fortunately they tap at my love lingo. Yeah. All right, so that's reflection in the what? In the y-axis. Okay, reflection in the y-axis is not difficult. It's very easy, but we just need to make sure, guys, that we take care for the hyperbola. We can't leave it like this. Okay. Oh, is it? Thank you to your nephew. Your nephew is too kind. Your nephew is too kind. Is your nephew doing grade 12 or grade 11? By per chance. Okay, let's move on now to the next one. Okay, what about the exponential function? If you are having the exponential function, grade 11, beautiful ish, nice grade, that one. Your nephew should probably be doing the things there with the grade 11. Grade 11 is a very nice grade. It's a very nice grade, that one. Yeah, so this is just to accommodate, we're revising some aspects there for grade 11. Okay, f of x is equal to 2 times 3 to the power x minus 2 plus 4. Okay, so if they say the same thing, all right, they're saying the graph of m of x is obtained by reflecting the graph of f of x in the y-axis. Determine the equation of m of x. Once again, where are we reflecting? In the y-axis for the exponential function. So are we doing anything different from what we did before? Not really. It's just that we have an exponential function. Otherwise, the application of the concept is the same. Okay, reflection in the y-axis means who stays the same? Y stays the same. Who changes? X. Who changes? X and its sign. So that means we are going to say m of x is equal to f of negative x. Then, where do we go? We go to the x there. Go to the x there. 2 times 3 negative x minus 2 plus 4. We go there. Does that make sense, guys? That we go there. Yeah. Now, once we go there, we don't end there. Okay? It's unfortunate that many times learners do the substitution, then they lose marks because they do not basically simplify the function to its ultimate end. Here you see what we did. I said to you, we need to avoid having a x that has a negative sign. So we factorize the denominator and then we we divide so that we establish the sign of the numerator, which is negative, and then obviously the expression in the denominator is always x plus or minus something. So that is true to its functional form. For the exponential function, we need to also be true to our functional exponential form. So what do we do then? Well, very simple, guys, what we do. Very, very simple. So now that we have this, we are going to do that thing. We are going to take out the highest common factor. So let's take it out. Take out the negative sign, SNL sign, number, -1, no letter. We are left, remember when you take out the negative, the signs of the expression change. Does that make sense, guys? Am I sense making? +4. Yeah, I hope I'm making sense because it's important. It's important that we make sense of this. Making sense of it is very, very important, yeah. Or what? Or what? Or whatty then? Yeah. Then remember, the function form of the exponential, y is equal to ab to the power x plus b. There is something here that we need to take note of. A can either be greater than 0 or less than 0, depending on the a value. B can either be greater than 1, or B can be between 0 and 1. Right, so these are the expected norms of B and A. So if we look at B currently, we have 3 to the power, and we're like, what's happening here? Okay, there's a negative. So that's why it's very important to note it's 3 to the power -1 that we have there. So then we can continue then and say 2 times. Remember, exponents, a to the power -n can be written as 1 over a to the power n. A to the power -m can be written as 1 over a to the power m. This is a very important notation here. Writing your exponents from a negative exponent to positive exponents. The simplified form of any negative exponent is that we don't leave our answer as having a negative exponent. Just like we don't leave our answer for the denominator in the expression having a negative x. So in the same vein, it's like we can't leave our exponent there being negative. Okay. Sorry, guys. Sorry about that yesterday. Okay, so 3 to the power -1 can be written as 1 over 3. Then you can write to the power x plus 2. Does that make sense? So 2 times the 3 to the power -1 can be written as 1 over 3 to the power x plus 2 plus the 4. This is how you want to leave your final form. And it is the application of the exponential definitions as learnt in grade 8 and 9 that we apply. The negative exponent must be written as a positive exponent. Okay. Yeah, so this is very important. Okay. Yeah, Sfundo, what I'm going to do is I'm going to download this video after I'm done, and I'll post it onto my YouTube channel. You know, most link is in the bio. You can watch it at your own time, my guy. Yeah, because I started, it's been a while since I started, so like 6-ish. So it's been on for quite some time. So don't worry, just don't worry. So here is the function, guys, of m of x, ne? Yeah, function is verified. Yes. The link to the YouTube channel is in my bio. TLG, can you please do the revision of the analytical and the trigonometry? Yeah, well, I can always do that, but let us plan for it. Let us plan for it rather than me just sporadically do it. Okay. What grade are you referring to, by the way? Yeah. Okay. So yeah, just something else on the side here. I've been actually looking. I've been wanting so badly to start a grade 11 group. Um, but like a grade 11 paid group. You know what I mean? Monthly paid group. But like a group of grade 11s that I can help every single day. They can join my private TikTok lessons. I have a private group for grade 10s, for instance, that join every day, 9 p.m. We have a lesson every day. Currently, what I'm doing with the grade 10s, we are revising or reviewing the term 1 and term 2 work, because I could see that there was an outcry. And what I'm scared of is most grade 10s that are doing pure maths will have been crazily become despondent after writing the junior exams. Why? Because the term 1 work was sweet. It was a review, a recap of grade 9 work, like factorization, solving equations, like very similar work that they were doing. Term 2 comes around. Now they have to be exposed to what? Trigonometry. Well, sorry, end of term 1. They get exposed to trigonometry. They get exposed to functions. Functions is a new topic altogether. It seems a bit overwhelming. And for a grade 10 learner who's doing pure maths, they're like, what in the world is happening? Then they write the junior exam, which has both term 1 and term 2 work. And most of them, they flunk, or they basically cannot handle the pressure of everything else. It's not just the maths, but everything else combined. And then they do badly. And then most of them want to stop doing pure maths. So what I've done is I've picked up a few of the grade 10 learners that have been joining my live lessons every once in a while on TikTok. And I've said to them, talk to your parents, let's have an arrangement. Let's meet every day. Like I'm meeting daily with them, 9 p.m. to 10. It's a standard time that we're meeting. We have a lesson, and all I'm doing is I'm recapping on term 1 work. We're doing like basic, simple sections of the term 1 work and the term 2 work. We'll be getting into term 2 very soon. And then after the live lesson, I send them some work in the group on WhatsApp. They do the work, they send it back to me, I mark them, I give them feedback. And then if there's something that's not clear in the live lesson I have with them subsequent, we then go through any corrections or anything that they seem like they did not get conceptually. Then we move on to the next concept the next day. And what I'm finding is that some of them, they are really becoming that much more confident. And it's like they're getting very good at the maths. And because we're doing it daily, like, because most of them are told by their teachers, please practice maths every day or do maths every day. But you see, the thing is, for a grade 10 learner to have such needs a lot of commitment. So at least now that they have me sort of like having the lessons with them every day, it makes life easy, right? Because now they are doing maths every day, and they have a standardized time where they know that maths is happening. So I've been wanting now to have a grade 11 group. Grade 11 group would basically be a group that I would have from that grade 11 group, I would basically probably have lessons or sessions with them. Now that I'm free, because I was busy in the holiday with another program, but I'm free now up until schools reopen. Guys, I'm a teacher. I am a teacher. Besides being a tutor online, doing whatever, I'm a teacher, and I'm a very good tutor and teacher at that. Like both, my learners do very well at school. At school level, they do very well. At least the ones that basically are with me, because unfortunately, not all learners are with you, but the ones that are with me and the ones that basically take direction from my mentorship, they do very well. So are you still open to take someone for grade 10? Yes, yeah, we can take someone for grade 10. Like I said though, it's at a price, so it's at a monthly standard price, and all I'm charging is 500 rand per month. Because you think about it, I am having a session with these kids every single day, and I'm marking their work every single day. They get personal feedback from me every day, and when they are on WhatsApp with me, they can ask me questions any time of the day, and I support them above and beyond. So it's a standardized 500 rand per month, and it's just to ensure that their maths marks are respectable. Level 5 and above, guys. That is basically minimum. But if a learner is really with this thing, like they can start getting 90s, like literally, like getting 90s, solid 90s and above. And that's the whole objective, making maths easy, accessible. So the grade 10 group is still open. Just make sure you contact me on the site, because we are standard having sessions with them. grade 11 group, like I said, I'm looking to start that one. So those who are interested can just DM me so that we can have that happening ASAP. Because funny thing is, I've been having a hard time finding grade 11 learners. Yeah, grade 11 learners. I don't know, maybe grade 11 learners seem a bit, they are self-sufficient. That's probably why. So you guys let me know. But yeah, just contact me on the side. You can DM me, send me a private message. I'll get back to you as soon as I'm done with the live. Don't worry. Don't worry. Okay. Yeah, so let's see if we can't have that happening, Yabo, because the consistent help, it helps a lot, and the support. Then those kids, they can ask me questions anytime. I can help them anytime. Besides the standard lessons, but anytime. So, yeah, man, let's get the grade 11 performance up there, man. It has to. Okay, let's move right along. The last function question that we have here. Okay, the graph of m of x is obtained by reflecting the graph of f of x in the y-axis. Now we are going to the parabola this time round. Remember, the parabola f of x is equal to, yeah, that's the thing, is it? That's the problem. What I'm finding is that most learners are not bad at maths, just that there's a lot of gaps. Some of these gaps have been created by you, the learner. You created them because you didn't pay attention in earlier grades. Because the thing is, unfortunately, maths is like, I don't know, like yeah, it is a continuous, you build from previous. If your foundation from previous grades is not solid, what happens is that you get asked a question that you are not familiar with. And the reason why you're not familiar with it is because the concepts maybe from some of the grades you did not grasp. Okay. And then it becomes a difficult question. But for someone who has understood their concepts from basic grades, then it becomes easy. One of my learners from I taught a metric class last year. One of my learners in grade 11 that got 100% consistently throughout the year, and also like in grade 12 was getting consistent 100% every single year. Just at the end of the year, that the paper from last year, grade 12, was quite difficult, I must say. And the most learners basically dropped in their performance. That learner finished off the year with 97% in maths grade 12. So one of the things I remember him saying, because this learner was a poor student in grade 9, one of the things that he said was like the basics really help. When you understand the basics, it's easy. Another learner of mine that got 100% in maths, another learner that we're helping in the program, also was saying the same thing, that basics. You need to understand the basics of maths. If you understand the basics, then you top up on the basics and you can expose yourself. You learn basics, but then you expose yourself to different types of questions. But you need to first fundamentally understand the basics. Then gaps need to be closed. Yeah. SA2 ngai functions. You just need to walk through them. It's as simple as that. Like there's no magic formula. You need to actually literally go from one function to the other and go through them so that you can understand functions. Otherwise, there's no quick fixed formula, like understand the. So what I've been doing the past few days is I went through all the functions. Like every morning I've been doing a function a day. Today we are looking at interpretation, because we've done straight line, we did parabola, we did hyperbola, the form of the function, how to sketch it, the equation, how to find the equation. Okay. Let's say Tungai, do I have a group for grade 12s? Yeah, that I do have a group for grade 12s, but it's not, I must say, like it's not a group that I'm not proactive in that group, because those grade 12s know very well that in grade 12 I tend to let them fly on their own. Why? Because varsity is not really spoon feeding. Okay, I spoon feed my grade 10s and my grade 11s big time. Why? Because we need to lay the foundation. But once the foundation is laid, I really work on a basis of, you need to also establish a sense of independence. If you have a question, you must ask it. If you want help with something, you must ask me for help with something. I must help you with that particular thing. So those grade 12s, they know. They know. Because the reality is that no spoon feeding happens in varsity. So it's kind of like precursoring the year ahead. F of x equal to x squared. Sorry, guys, I'm talking too much now. Let's move on. We wanted to find the reflection of the function, okay, of f of x, the new function, m of x, when it's reflected along the line x is equal to 0, or we can say reflected along the y-axis. Remember, reflection on the y-axis means we do what? Who changes? Reflection on the y-axis means x changes. So let x change, guys. Okay, let x change. When x changes, the x here, the x there. So, sorry, I forgot to write this first. Reflection in the y-axis means m of x is equal to f into negative x. So that means x changes sign. You see, this x was positive. Now we say negative x squared plus 5 into negative x plus the 6. Obviously, the 6 is going to be unaffected because it has no x. Okay, please, guys, you put the negative x in brackets and then the square. Okay, because I think most learners, they do this, and that's where the problems basically start. This is not what we do. We do this. Okay, are you feeling me here, guys? We don't do this. We do that. Okay, please. Otherwise, if we do that, problems here. Okay, so we do that. Okay. Are we following, guys? What was the question? The graph of m of x is obtained by reflecting the graph of f of x in the y-axis. Determine the equation of m of x. I repeat, the graph of m of x is obtained by reflecting the graph of f of x in the y-axis. Determine the equation of m of x. That was the question. So what do we do when the graph of m of x is obtained? By reflecting the graph of f of x in the y-axis. Remember, in the y-axis means what? So here is f of x. Okay. When they say a reflection in the y-axis, it means what? Y stays the same, x changes sign. So our x changes sign. That's why here in the place of x, we have negative x. So we are going to substitute in the place of x that. Then we brackets square plus 5 brackets negative x plus 6. Then we go ahead. Exponent that is even applied to a negative sign means the negative sign becomes positive. Then the x squared, that is positive. Positive times a negative is negative 5, negative 5x. You would be very wrong. You're very wrong. Sifundo, that means you have no understanding of the concept. Reflection in the y-axis means x changes. So functionally, m of x is the new function. How is it formed? By reflecting f of x in the what? In the y-axis. What does that mean? It means there's a change in x. How? In the sign. When you divide by a negative, it means that is not comprehending the concept. The concept is misunderstood. If you are going to do that, goodbye. Sorry, guys. Reflection in the y-axis, change in x, y stays the same. Reflection in the x-axis, change in y, x stays the same. So we need to be clear about that. Okay. So remember, when we reflected f of x in the x-axis, we said, what is the function of h if f of x is reflected in the what? In the x-axis. Then we said we change y, because remember f of x means y. We change y, so you say minus multiplied by f of x. You change f of x from positive to what? to negative. Then you write down the function of f of x. Then in brackets, you put the negative sign, you distribute it. This would be your function reflecting f of x in the what? In the x-axis. Okay. The concept is found in this. This is the concept. Please, guys, the concept. If you understand the concept, okay. So this thing of division by negative, where is that coming from? Okay, that is a misconception. So you must understand the concept first. Okay, let's grasp the concept, then run with the concept. Otherwise, we don't grasp the concept and run with the concept, then we are going to add our own little, you're going to add our own little spices there. And those spices, they are the ones that we are going to find. You are adding spice to cake. You can't add spice to cake, my guy. No, we don't add spice to cake. We don't do that. Reflection now in the y-axis. You see, now we are reflecting in the y-axis. What is the concept? The new function is m of x. What do you do to f of x when you are reflecting f of x in the y-axis? The change of sign in x. So it's f of negative x. Then what do you do? In the place of x, you substitute what? Negative x. Then you simplify. Please, guys. Now the new function of m of x, when f of x is reflected in the what? In the y-axis, is x squared minus 5x plus 6. That's the new function, the new equation. Are we tlhaloganya, guys? Yeah. If we understand, then we are fine. Okay. Aim for humans, thank you so much. Thank you so much. Yeah. Thank you. I appreciate it. It's too genuine and organic to lack any acknowledgement. Sfundo. You are taking me back, my guy. Okay, you are taking me back. Reflection on the y-axis. I've just explained now. Yes, please explain. I am explaining. You're not. Are you listening? Okay, so let's just fundo for you. Okay, I looked at some examples here. Okay, we had the Cartesian plane. All right, so I was looking at reflection in the x-axis. All right, and through an example, I was saying, if you have a point A, which is 2 and 3, and then it says we reflect this point along the x-axis. There are two things that we need to understand about reflection in a particular place. It means that where along the place where you are reflecting, you are going to have the points being equidistant from where you are reflecting. In other words, the distance from A to the x-axis is the same distance from the x-axis to the point where you are reflecting. Okay, so we could say, for instance, the distance here is 3 units, because from 0 to 3, negative 3 is 3 units, and then from 0 to positive 3 is also 3 units. So the points are equidistant to the region of reflection, which is the x-axis. But please take note now, because the A and the point reflected are on the same vertical line, that means our x values are the same as we look at the reflection along the x-axis. X stays the same. Sifundo, I hope you are learning the Sifundo, my guy. Then y, this is 3, this is negative 3. The y value changes, but how does it change? It is the sign of y that changes when we are reflecting where? In the x-axis. Sometimes examiners don't say reflection in the x-axis. Examiners sometimes say reflection in the line y is equal to 0. Then the minute examiners say that, people get lost. It's like, what are they talking about? Guys, reflection in the x-axis. Remember, the x-axis has an equation, which is y is equal to 0. That is the same thing. So if we say reflection in the x-axis or reflection in the line y is equal to 0, we are still talking about reflection in the x-axis. Fundamental concept. X stays the same, y changes its sign. So this is when we are applying reflection to a point. Okay, there's the concept of equidistant from the line of reflection. 1. 2. There's the concept of the change of the sign of y when we are reflecting in the x-axis. And there's the concept of x staying the same because we are on the same vertical line. Any vertical line has the same x values. Okay, I hope we are together. Then, reflection in the y-axis. Different concept. Now we have B that has changed. If we look at B, 2 and 3, and you look at B reflected along the y-axis, that means who stays the same this time round? It's y who's staying the same. Who changes? It is x, the sign of x. Y stays the same, x changes sign. That means we are equidistant again from the line of reflection. Make sense? So reflection in the y-axis means y value stays the same, y x changes sign. So now we were looking at questions that have to do with the change in the equation of the function once it has been reflected. Now here we were saying, I want to go to the questions now so that we can, So we were given this function f of x. They are saying the graph of h of x is obtained by reflecting the graph of f of x in the x-axis. Sifundo. Determine the equation of who? Of h of x. So who is being reflected? F of x. Where? In the x-axis. To form what? To form h of x. So h of x is a new function. Reflection in the x-axis means what? Y changes. Remember, f of x means y. Who changes? Y of who? Of f of x, because f of x is the one that's reflecting where? In the x-axis. So we say negative. We multiply the f of x with negative. That's what we do because we are changing the sign of who? Of f of x. Then look, we substitute f of x, which is 2 over x plus 1 minus 3. This is a function that consists of two terms. We write it in brackets. We take the negative, we distribute it inside the bracket. Negative times 2 over x plus 1, negative 2 over x plus 1. Negative times the negative 3 is positive 3. This is the new function of h of x. When what? When f of x is done what? Reflected where? In the x-axis. What happens? Y changes. How? The sign of y changes. So what we do is we multiply by negative. You can do that for the hyperbola. We can do that to the exponential. You can see. We can do that for the parabola. You can see. This is all reflection where? In the x-axis. Why? Because reflection in the x-axis means y changes sign. Are you with me now, Sifundo? In the comment section, Sifundo, you need to comment and say, yes, sir, I'm with you. No, I am not. Are you with me now, Sifundo? Okay, I see some other people are with me besides Sifundo. Okay, thank you. Then do you need me to explain reflection in the y-axis as well as pertaining to the function? As pertaining to the function, we looked at a reflection now in the what? In the y-axis. A reflection in the y-axis. The formation of f of m of x when f of x is reflected in the y-axis. Remember that the y-axis is also the line x is equal to 0. They could say that instead of saying y-axis when I need to understand what it means. So we substitute my guy in the place of x now. We don't multiply this by negative. We substitute. So that's why this idea of yours that you had of dividing by negative, it cannot be applied for any of the two reflections. Okay? Please, Sifundo. Oh, then for the hyperbola, you can't leave the x in the denominator having a negative sign. It must be, you must factorize the denominator by taking out the negative. Then you see you have the expression x minus 1. Then you divide 2 with negative 1 to get negative 2 in the numerator over x minus 1 minus 3. This is the standardized final form. So the exponential function reflection in the y-axis, x obviously, you see. But then again, we can't leave the x with the negative sign. We take out the negative sign. Then we apply our definitions for exponents from grade 8 and 9. We apply the definitions of exponent, change the negative exponent to a positive. I hope you guys understand how a to the power negative n can be written as 1 over a to the power n. I've since learned that many learners don't understand how this becomes that. I've learned that, guys. Hey, you see, when you teach, you understand things. You get to learn that some learners, they just memorize for the sake of memorization. They don't understand. So I want to explain this. A to the power negative n. I want to show you something. There's a scripture that says, God is before us, He is above us, He's like protecting us from every front. His angels are round about us to bear us up. A lot we go through, but we don't understand that we are surrounded. So here's the thing. I usually say the number one is like the invisible entity, God. I'm not saying one is God, but I'm just saying it's like, right? Unseen, but present. So here, for instance, is an invisible one. People don't usually acknowledge it, but it's there. At the bottom of this A, there's an invisible one. Often neglected, but forgotten, but it's there. So if you think about it, the law or definition of exponent says you cannot write a positive, and you can't leave your exponent being negative if you are simplifying. Okay, so you must make sure that this has a positive exponent. The way you do it is the 1 at the top is multiplied to a, so it gets left behind. But any base raised to a negative exponent changes position. So this a moves from the numerator, goes to the denominator. The exponential sign changes from negative to what? To positive. The 1 that is left behind is that 1 that is unseen, that is multiplied to the a. That's why most people don't understand that it's actually 1 over a to the power n. The 1 that was there gets multiplied with the a. It is still there, but unseen. So we have an answer of 1 over a to the power n. Any base raised to the negative exponent changes position. That particular base that is raised to that negative exponent changes position. Then the sign of the exponent changes from negative to what? To positive. Once you understand that, then you should be fine. There's no need for me to do other examples, Sifundo. When you just need to understand the concept of reflection. The rest is simplification learned from earlier grades. That is basically the thing about maths, guys. So most of you would probably have no problem understanding the concept and the substitution of negative. There it is. You put the negative in the place of x, negative x minus the 2, which was already there. Where people will lose it is the factorization, taking out the highest common factor from negative x minus 2, which according to SNL, sign, number, letter, remember guys, that one, the movie thing, negative 1 you take out, you're left with x plus 2 in brackets, plus the 4. Then, hi guys, from there, the 2 stays times the 3 to the power negative 1. Now you need to apply your law. Take the 3, write it as 1 over 3 in brackets. Then you put x plus 2 outside, as it was the exponential expression that was there anyways, plus the 4. You are done. You are finished. You are done. That's it. Okay? That's it. So I don't need to do another example of exponential. When you need to practice the concept so that when you can be fine with the concept. Okay, so Sifundo, don't make me do your work. When you must do the work that needs to be done. I'm just here to help unclog the blocked drain, to also remove the cobwebs that are there, so that the spiders can flee away and you can start having clarity of mind with the concept so that you can apply it correctly. Make sense? Yeah, Sifundo. Yeah. You're becoming a baby when you want me to do things for you. Then with the parabola, f of x is equal to x squared plus 5x plus 6. Same thing. If we are reflecting f of x in the what? In the y-axis, and we are forming a new function m of x, what does that mean? You change x, guys. So there, I said we do this, we don't do that. Not this, guys. We substitute the x that's negative there. You know? When you are writing the exam, you're not a baby then. Okay, that's why I don't like treating metrics with this baby mentality, because it's a lie. It's a lie. It's not a precursor of what's going to happen in high school, in university. M of x is equal to x squared plus 5 minus 5x. You see? Yeah. Then that is the new function. Okay. So the concept. Hopefully now you understand this point. You've learned your lesson. Okay. So guys, yeah, that basically is in summary. Okay. We looked at translation today. Okay. Vertical translation, shifting the graph up and down. Okay. Yeah, very much so. Then 3 units to the left or right, we looked at that. We looked at this concept, vertical and horizontal translation, as it relates to a hyperbola, exponential, and our parabola. We looked at the application. Then we looked at the reflection in the x-axis as well. Okay. Yeah, and then we looked at reflection in the y-axis for all 3 of the functions as well. So hopefully you understand it. And guys, as I said, to those that have been obviously with me as we've been doing this, these notes are extracted from Jen. Jen is a very, I must say, they are a national asset to the country, helping out learners across the country in various centers and so forth. I think they're in operation even now, and they provide notes to basically assist the learner. So I am just utilizing them to basically explain and simplify some of the things as well. I guess it's one thing to have notes, it's another to have those notes explained, right? And to also have a little bit of, added explanation in certain areas where maybe things were not as clear. Okay. So yeah. All right. So grade 12s, tomorrow I'll be doing the your inverse functions. Okay, so grade 12s tomorrow morning. All right, I'll be doing inverse functions for you all so that we can get that inverse function happening. Okay, and then we'll do other interpretation questions or interpretation type so that we can have that understand. I want to do one exam type question here. Okay. Because of the absolute amazing love that I have. This here, for any grade 10 learner that is watching, this is a grade 10 question. Why do we know that this is a grade 10 question? Look, the graphs of f of x is equal to x squared minus 4. This form of the function, you're welcome, AM for humans. Yeah, I guess I don't know your name, so I have to just go off the AM for humans. But thank you so much. You are so welcome. I'm glad that the session has been helpful for you. Yeah, big time, big time. I'm just gonna spend 30 minutes just looking at this question. Not really answering the questions, but I just want us to look at the question. So here, f of x is equal to x squared minus 4. This is your quadratic form of the function as per the form that is given in grade 10. Okay, ax squared plus q. Okay, and then here we have a straight line. G of x is equal to negative x plus 2. So this is a parabola. This is a straight line. Why do we know it's a parabola? Anything with x squared in the numerator, parabola. There's no other x value. Anything with an x raised to the power 1 is a linear function. That means it's a straight line. So we know that this here is our straight line. Immediately when I look at the coefficient of a here, x squared has a coefficient of 1. That is a positive 1. That means, in other words, that a is equal to 1, a is greater than 0. There should be sense in the a when we look at the form of the function. So if you look at the parabola, that it's concave up, it's smiling, makes sense because a is 1. Smiling face. It makes sense, guys. You see, this is relatable. It's perfect. Look at this function, the straight line. The m, the coefficient of x here is negative. Remember, when we did the lesson on the straight line function, we said when m is equal to -1, then the shape of the function or the direction of our straight line is a decreasing line. You can see here, it's decreasing. So if you look at the shape of the parabola, looking at A, makes sense. If you look at the coefficient of x, which is -1, look at the straight line. It's a decreasing straight line. Makes perfect sense. Then remember here, we said this is for the parabola, we say this is the y-intercept in grade 10, but it is also the turning point. Y is -4. So when x is 0, y is -4. There, that would basically be the 0 and -4. Makes sense because below the x-axis, our y values are negative. That being y, which is -4, and the x being 0 because it's on the y-axis, makes perfect sense. So this, it's too much sense, guys. You know, so these are the beautiful things. These are the things that when you look at a function, being able to relate it back to the sketched function, then you can make sense of what you see there algebraically to the visual sketch or representation. And you check your concepts in the process, that you've understood your concepts well. Look at the straight line. As I said, it's a decreasing straight line because the coefficient of x, meaning the number that comes before the x value, is negative. If you look at +2 here, that is the y-intercept, okay, where the graph cuts the y-axis. It's +2. This d is situated above the x-axis. The y values here are positive. So that being +2 makes sense. 0 and 2, the coordinates of d being 0 and 2 makes sense. Look at the first question. Write down. They're not saying calculate. They're saying write down the coordinates of C. So already I can see which function is passing through C. It's the parabola. What is C? C is the y-intercept. How do I find the y-intercept? You let x be equal to 0. But of course, mentally, if you substitute 0 here, 0 squared minus 4 is 0 minus 4, which is -4. The y value is -4. So the coordinates of C, the x coordinate is 0, because this is on the y-axis. X is equal to 0 everywhere on the y-axis. The y coordinate is -4, because remember, this Q value also indicates the y-intercept as well. Okay, for the parabola in this form. All grade 10s should know this. Grade 11s should perceive this. Grade 12s should be masters at it. So this one, straightforward, to the point. Straightforward to the point. Thank you so much, Haim, for contributing to my live goal there for you awesomes. I really appreciate it. Yeah, guys, the contribution to the live goal makes me happy. Thank you so much. Much appreciated. I'm sorry, I'm gonna call you Haim this long because I don't know what's your name, so I'm just gonna call you Haim. Oh, Nana. Oganye is, I'll just call you Nana. Okay, so then here, straight line. There. D represents the y-intercept. We let x be equal to 0. Yeah? So therefore, there. Okay? 0 and 2. 0 and 2. C and D. Okay, Nana. Nice meeting you. Nice knowing you. So write down the coordinates of C, 0 and -4. Write down the coordinates of D, 0 and 2. Okay, guys, on the y-axis, this has the equation x is equal to 0. Okay, this is basically the values of x everywhere on this y-axis. X is 0. Okay, so that's why we can confidently say that the coordinates of C are 0 and -4, whilst the coordinates of D are 0 and +2 from the straight line. Let's continue, guys. Let's continue. There's something more told here. A and B are the x-intercepts. A and B are the x-intercepts of F, meaning the parabola. What are x-intercepts? X-intercepts are where the graph cuts the x-axis. We know that the x-axis has an equation which is y is equal to 0. So if you want to find any of the corresponding x values here, you let who? you let y be equal to 0. If you want to find any of the corresponding y values on the y-axis, you let who? You let x be equal to 0. Make sense, guys? Make sense, these things. Then we are told C and D are the y-intercepts of f. There's C, y-intercept of f. Here's D, y-intercept of g, respectively. K is a point. Where's K? There is K. K is a point on G. There is K. K is a point on G. Such that BK, this is BK, is parallel to the, I think they were supposed to say y-axis here. Okay, can't be saying BK. Here's BK. This is BK, right? So if you're saying BK is parallel to the y, not x, this is the y-axis. So it has to be parallel to the y-axis. F and G, F, which is the parabola, and G, which is the straight line, intersect. What does the word intersect mean? That's where they touch and say mwah, right? That's where they touch and say mwah. F and G, they intersect at A and E. That's where they have fun. They have fun there and there. Intersection. Okay? Yeah. Basically, that's where f of x is equal to g of x. Anything that has to do with two graphs intersecting, you can equate the two functions to basically be equal, and you can solve for x, get the x values for those points, and get the corresponding y values for those points. It's like solving two equations simultaneously. Determine the length of CD. If we know what C is, we know what D is. We are on the same vertical line. Think about it, guys. We know what D is. We know what C is. We want the length of CD. So there is a shortcut. I know, guys, that you guys know that there's a distance formula. Okay, but that is obviously a distance formula used in your analytical geometry. You can use that, but I mean, the shortest way is saying y at the top minus y at the bottom. Especially, guys, we can apply this with a vertical line. Remember, D and C lie on a vertical line. In other words, what do we see here? X values are the same. If your x values are the same, it's easy to just take your y values at the top. What's your y value at the top? It's the y value of D minus your y value at the bottom, which is your y value of C. Y of D is 2. The formula already has a minus sign, but the C value, the y value of C, is negative 4. So it's 2 minus minus 4, which is like 2 plus 4, because the negative times the negative is a positive. What's 2 plus 4, guys? It is 6 units. Okay, so hopefully you understand that grade 11s and 12s, because a grade 10 would know, right? Because as I said, this is a question that grade 10s would be asked. This is a grade 10 question, because your parabola is of the grade 10 form, and your straight line is obviously your grade 10 type. So this is a question that would probably appear in a grade 10 question paper. Okay, so we found down the coordinates of C, 0 and 2. We wrote down the coordinates of D, 0 and negative 4. The length of CD, very straightforward. When you say, when the x, it's on a vertical line. If the vertical line, it's a vertical line. Remember, any vertical line will have the same x values but different y value. So you can use y top minus y bottom, but you can only apply this for a vertical line. It's only applicable to a vertical line. Okay. If you want the distance on any other line, then you can use the distance formula. Okay. So the length of CD, 6 units. Calculate the coordinates of B. Where is B? B is our x-intercept. Of which function? The parabola. B is the x-intercept of the parabola. So what is the x-intercept? That's where we let y be equal to 0. So if you want B, remember B is on the negative side of the x-axis. So that means the B coordinates is going to have a negative x value, but the corresponding y value is going to be 0. So what do? If we want the coordinates of B, we let y be equal to 0. X squared minus 4 is equal to 0. What do we see here in this expression, the x squared minus 4? What type of factorization can we apply there? What do we see in the expression? X squared minus 4 is equal to 0, guys. What type of expression is that? What type of factorization can be applied there? What type? Type. Yes, if you were IV4. Thank you so much. Difference of two squares. Very good. Okay. Difference of two perfect squares. Any variable raised to an even exponent is a perfect square variable, and any number which basically can be formed by multiplying a natural number by itself is also a perfect square. So the square root of x squared is x. The square root of 4 is 2. So what we do is we say x and x, 2 and 2, we put plus, minus. This is grade 11, 12, and also this one specifically is a question applicable to grade 10. Functions, to be specific, okay? So x plus 2 into x minus 2 is equal to 0. Then we say x plus 2 is equal to 0, or x minus 2 is equal to 0. Brandley, what grade are you in? Or like, are you asking for someone? Please guys, if you have a child that's in grade 10, you want them to enroll in my winter program, you can come through, please. And also, if you are a parent has a child that's in grade 9, I want to early onboard some grade 9s. Any grade 9 who's interested in doing pure maths next year, but wants to be onboarded in a systematic program that can basically assist them from now until the end of the year, so that they can have a smooth transition going into grade 10 next year for pure maths. Please guys, DM me. You can send the parents of those kids my way. I want to have a group of grade 9 kids that I can start helping now. I can start helping them in preparation for term 3 GEC and GEC end of the year. If you are a GEC grade 9 that's in a GEC school, we can get you prepped for that early so that you can be in a good position to get good marks in term 3. Because remember, your teachers are not looking at your marks in term 3 to check whether you are eligible to do pure maths next year or not. Because I know some schools are very strict with who they basically allow to do pure maths. I know some schools even have a test that you write as a grade 9 learner. So any of those guys, I want to onboard some learners with that, but I need the parents' approval and I need the parents to be on board so I can help and assist those learners. Okay, we'll have something systematic for them and help them get prepped for that. If I'm as a Jericho, I guess this is grade 9. Yes, this is grade 10 parabola. We are looking at a question. This is a grade 10 question, but obviously I was helping grade 11s and 12s. But then this question is grade 10, as you can see. See the parabola form, x squared minus 4. You see the straight line form, negative x plus 2. So we've answered 5.1, 5.2, 5.3. Now we want to calculate the coordinates of B. Okay, so we've basically established that B is an x-intercept of which function? The parabola. So we go and extract the parabola. F of x is equal to x squared minus 4. Let y, remember what is f of x? That is y. We let y be equal to 0. So in the place of f of x, we write 0. We solve for x, we factorize, apply the 0 factor law, get the x values. So this is the one that we were looking for, B. and y is 0, the x value there is -2 because we are on the negative side of the x-axis. So b is -2 and 0. Okay, that sorts that out. Then moving right along, 5.5, determine the coordinates of E, a point of intersection of F and G. That's E. They want the point of intersection of who? Of F and G. E is a point where the two functions, they and cross each other there. Okay, they touch and cross. Determine the coordinates of E, a point of intersection of F and G. Okay. So what we do there, we know point of intersection. The concept of point of intersection, POI, just simply means f of x is equal to g of x. Okay, that's what point of intersection means. Two functions are having a sweet, beautiful relationship there. So then we take x squared minus 4, we equate it. Remember, g of x is -x plus 2. So this, guys, is the concept of point of intersection. You equate the two functions, then you have an equation to solve. So that is why I'm saying, guys, you see, if now your solving for x skills are poor, then how are you going to get the values of x? But if your equation skills are top-notch, they are like out of this world skills, then when you're not going to have a problem. You understand the concept, you'll apply it, and then you'll be able to apply the solving of the equation. These are the things that we need to make sure that we are good at. So for instance, the grade 10 group that I'm busy with, that is paying, we are sorting out term 1 issues that have to do with expressions, your equations, your factorization, and all of those things. That's why I want now to have a grade 11 group, so that we can also help diagnose any problems from previous terms. And then we can sort those out, and then these kids, we can get them early started with the term 3 work. And then as we do the term 3 work, they can be sorted then in preparation for what's coming. And then final exams, guys, those ones, the maths will maths, guys. The maths will maths. The maths has no other choice. It has to maths. So we transpose x squared plus x. Remember, when a term transposes, the sign changes, so -x becomes plus x. -4 stays, +2 changes. Okay, we can see this equation is going to be quadratic in nature. So we have x squared plus x minus 6 is equal to 0. It's quadratic, the equation. Then you know almost how to factorize. Guys, because when the constant is negative, we know that means different signs. I love how one of my learners in the grade 10 group that I have was struggling with factorization, but now she's become this expert. It's like every single time I do a question with quadratic expressions that need to be factorized, she's quick to jump in and say, so this is what you do, and she explains it so well. It's almost as if like I'm so proud of how she's kind of like developed a big amount of confidence with factorization of quadratic expressions. So when the constant is negative, we know that we are going to have different signs. It's as simple as that. Coefficient is 1, constant is negative, that means different signs. If the constant was positive, it would mean same signs. Okay, but then we choose the factors of 6. Okay, obviously, because of the middle term being positive, it means the highest factor is going to have a positive sign. The highest factor is going to have a positive sign. So factors of 6 that will work. When I multiply, give me -6. When I add, give me +1. Which factors would be appropriate? I know grade 11s have the famous quadratic formula, but grade 10s don't. All right. Grade 12s also have the formula, and they can factorize. So it's really nice for grade 11s and 12s. Grade 10s factorize. So factors of 6. Okay, we have 6 and 1. That doesn't work. We have 3 and 2. We said the highest factor is going to have a positive sign. Because of the positive being there, then the other ones are going to be negative. If you multiply these, you will get -6. But which ones, when you add, will give you +1? The coefficient of x. It's 3 minus 2. So you put 3 here, minus 2 there. Then the x, just like that. apply the zero factor law after factorizing. Remember, you take the x plus 3 equated to 0, x minus 2 you equate to 0. Then you solve each independent linear equation, x is equal to -3 or x is equal to 2. What did we want? We wanted the point of intersection of who? Of E. Where's E? E is on the negative side of the x-axis. So if I come here, the negative value is what I'm interested in here, not the positive. Because remember, there are 2 points of intersection. There's going to be a positive value, which is obviously 2, which indicates that A. I'm not interested in that one. There's the negative x value, which is what I'm interested in, because the question says determine the coordinates of E, a point of intersection of f and g. So x is equal to -3 is what I take. Let's leave that one for this specific. So that x is also equal to 2. Actually, let's just leave it like that. Let's not cancel it out. Okay, let's just take what we need. We want to substitute x is equal to -3. You can substitute it into any of these questions. Okay, no, Neil, you are the one that has got wounds of trauma, my guy. You need to heal. Okay, especially if you are actually a math student that's going to continue being a math student, and you are still in early grades. You need to heal, my guy. You need to heal. Okay, f. Okay, let's substitute there. Okay, so that we can get the corresponding y value. I'm on -3, not -2. What am I doing? What am I doing, man? What am I doing, man? Sorry, guys. -3. I was supposed to say -3, not -2. So -3 squared. 9 minus 4. That gives you 5. Does it make sense that y is 5 if you look at where E is located? Yeah, in this quadrant, the y value is positive. The x value is negative. So it makes sense. So there it is. It's fine. Khontle, I have lost hope. What grade are you in, Khontle? Losing hope sometimes is a good thing, because sometimes you need to lose hope in order to gain renewed hope, and sometimes you need to lose hope, complete absolute hope in yourself, and get renewal. You're in grade 12, so I'm guessing you got level 1. Is that what is that pure maths? You got level 1 for term 2. Is that what happened? You got your report and everything. -2 and 5 there. Okay, that's E. -3 and 5. Yeah, see these people. -3 and 5. Keep on saying -2. I don't know why. From 6 to 3, no ways. No, Khontle. It is yes ways, actually. It is yes ways. That's very possible. Okay. And Khontle, you got level 6 in term 1, didn't you? Term 1 was a romantic term. There's no term of romance than term 1 in grade 12. It's a romantic term. Why? Because in grade 12, term 1, you are only focusing on the topics that are in term 1. What happens with term 2 is that you write 2 major exams, paper 1 and paper 2, and grade 11 aspects come in together with grade 12 work. So those are full papers, both paper 1 and paper 2. So most people then can't handle the overload because they don't prep for it. So when you need not be despondent, you just need to realize that in actual fact, you were underprepared to write your June exams. But now you need to take those papers that you wrote in June and go and close the gaps that you felt were there with those papers, so that you can then close the gaps for your September trial. Because September trial exams, guys, are like upon you guys. Grade 12s, you're going to be writing September trial exams in no time. August is here. September trial exams start in August, not in September. So you need to be realistic about what you knew when you're writing June, and don't be demoralized by that. You know, failure is the best teacher. So if you went from level 6 to 3, you can bounce back from level 3 back to level 6 and more. But it all depends on your response. But if you're going to stay in despondent mode, then you are basically going to delay your time and your effectiveness in being able to locate where the gaps were, where the problems were, and then actually dealing with them head on. You know, you need to be very decisive now, because you have no time to sit down and feel sorry for yourself. You felt great when you got level 6, didn't you, in term 1? I'm sure you felt like you were on top of the moon. But remember, it was only a limited amount of work. June showed you flames, rightfully so, because it had to show you flames so that you do not become unrealistic about September and your November final exams. So get up, girl. Get up, girl, if you're a girl. Get up, boy, if you're a boy. And get your marks, man. Get your marks, man. Okay? Anyways, that's my little pep talk to you. Otherwise, you can turn around that situation. Just as well as you turned around the situation for bad, you can turn around that situation for good. All right. Okay, so I think that's it now. At least you didn't get level 1, you got level 3. It's a lot of hope, guys. It's a lot of hope. You could still turn around. That story can be rewritten very well. Okay, let's look at the last few questions, guys. For which values of x will? 5.6.5.6.1. Very beautiful question. Very nice, this one. Very nice. For which values of x will? Where will f less than means below? Where will f be below g? In other words, where will f be under g? Where will f be underneath g? Who's under? He is under. He is. Okay. So we want f. We want to find out where is f and who's under. Here's under. Where is f underneath g? So he is below, he is above. F below g. So we are looking for the x values. Okay. So these x values, we check them from the left to the right. And I usually say to learners that in order to know these x values, 1, you need your x values for the x-intercept. 2, you need your x values for the y-intercept, which is clear because x is equal to 0 for your y-intercept. 3, you need your x values for the point of intersection. You're welcome. You're welcome. You're welcome. You're welcome. You're welcome. You're welcome. Thank you so much for joining in, and thank you for the gifts. You've been very, very generous and kind. I want to super duper awesomely appreciate you. You've been really, thank you so much. Thank you. Thank you. Send love to initially the person who joined, because the person who initially joined. Thank you so much. You've been really a great support. My nephew Luyanda, yes. Thank you so much. You guys have been amazing. I really appreciate it. Thank you, Luyanda, and thank you, Luyanda. I hear you were the one that's been gifting away like crazy, so I thank you so much for that. And Nana, thank you so much. You've been very kind. Very kind. Hopefully we will cross paths another time. So I usually say know all your x values for the x-intercept, your x value for the y-intercept, your x value for the point of intersection, and then lastly, if you have your vertical asymptote, you need to know your x value, which in grade 10 is always x equal to 0, but you need to know your x value. These are the x values that you need to know so that you can be in the position of answering these questions. These questions can only be answered when these x values are known. So I'm just going to do a rough sketch of this function because I want to have the liberty of my soul. Okay, that was a bad drawing. Just want to have the liberty of the sketch. Okay, I know guys it's not perfect, but I'm sure you get the point. Eh? You get the point, you get the point, you get the point. The point is got 10. Okay, so what I'm saying is that we need the x value for the point of intersection. So this x value here, make sure we have it. Remember, we found that x value. We know what it is. It's -3. The x value here at this x-intercept, that is -2. The x value for the y-intercept, that is 0, as we have it there. The x value of the other point of intersection, we know if that is -2, that's obviously going to be 2. We don't have an asymptote. So now we use these x values to be able to write. We're going to, because they are saying for which values of x will f of x. Oh, this is below. Yeah. Okay, where is f below g, right? So f, where's the function of f? Here's the function of f. Where's g? Here's g. So guys, what we do, you see this first x value, it's -3. Okay. Then we look what's happening before -3, this x value. Where x is less than -3, what's happening to the functions? Who is at the top? F is at the top, whilst g is at the bottom. Okay. Tina, when we say f is below g, we are saying f, who's at the bottom, who's at the top. So Tina, we're looking for situations where f is at the top. F is at the bottom and g is at the top. Okay. So if we look at when x is less than -3, what's happening? F is at the top whilst g is below it. It will continue to be like that from -infinity to -3. So where x is less than -3, that is where f, no, sorry, no, never. F is at the top. Now we want where f is at the bottom. Okay, because remember we say f below g. So where x is less than -3, who's at the top? F is at the top. Who's at the bottom? G. Okay. Yeah. So there's no answer here. That's not an answer. This would be a nice answer if they had said f of x is greater than g of x. If they had said where is f above g, then x is less than -3 would have been a great answer. Okay. Now let's look at this interval between -3 and -2. What's happening? Between -3 and -2, this function g is on top, but f is below, between -3 and -2. In fact, from -3 to -2, f is at the bottom. From -3 to -2, it's like that. From -2 to 0, it's still like that. From 0 to 2, it's still like that. So where are we having f being below g? It's from -3 all the way to +2. So how do I write that? I can say x is greater than -3 but less than 2. This is where f is below G. Okay, guys, look, who's at the top? G is at the top. Who's at the bottom? He's at the bottom. Who's at the top? He's at the top. G is at the top. Who's below G? F is below G. So we are looking for where F is below G. Okay, so F is below the G all the way from here to there. What's the X values? X negative 3 to 2. You can write the answer in two ways. You can either say this, or you can say X is an element from negative 3 all the way to 2. That's interval notation. All right. So two ways of writing the answer. You can write the answer that way, or you can write the answer that way. It's really up to you. Okay. Then from 2 onwards, what's happening? F is above, meaning F is at the top, G is below. So we are back now to F being above G. That's where X is greater than 2. We could say F is above G. So our one answer for this question, where is F below G? Guys, please, you look from left to right. You use your X values for the X-intercept, your X value for the Y-intercept, your X value for the point of intersection. If there was an asymptote, we'd use the X value for the asymptote. But here, these are our X value for the point of intersection, the X value for the X-intercept, negative 2, the X value of the Y-intercept, which is 0, X value of the point of intersection, which is 2. We're looking at this interval, what's happening. This interval, who's on top? F is on top. Who's below? G is below. Okay. Yeah. So no answer here. No. X less than negative 3 is this one. From negative 3 to negative 2, top is G, F is below. From negative 2 to 0, who's on top? G is on top, F is below. From 0 to 2, still, G is on top, F is below. At 2, they are both equal. Then from 2 onwards, F continues to be at the top, G continues to be below. No answer here. So our answer is only that. Okay. So please, guys, this is what you need to write the answer. You need your X values along the X-axis for what? The X-intercept, the Y-intercept, the point of intersection, and the asymptote if asymptote is available. So here, no asymptote. We have the X-intercepts, negative 2 and 2. We have the X value for the Y-intercept, it's 0. We have the X value for the point of intersection. The X value for this one is negative 3. The X value for this point of intersection is 2. Now we are ready to read the answer. We just need to first interpret what F of X less than G of X means. It means where F is below G. We are looking for places where F is below G. In other words, where F is underneath UG. Where is F underneath UG? So we look from left to right. We first look in this interval. Where X is less than negative 3, what's happening? F is above G. No answer there. What's happening from negative 3 to negative 2? G is above UF. So there's the answer. We have an answer there. But is that where the answer ends? No. It means also if we look at negative 2 to 0, still G is above UF. Let's look from 0 to 2. Still G is above 1 UF. Then we look from 2 onwards. No answer then after that, because F now is at the top, whilst G is at the bottom. So these are the things we look for this one. Okay. Omunye phezu komunye, guys. Omunye phezu komunye. We call these questions omunye phezu komunye. Okay. Please always check. If they say F of X less than G of X, it means F bottom. You're looking for where F is at the bottom whilst G is at the top. Okay. Who's at the bottom? Who's at the top? Who's omunye phezu komunye? Who's the one who is above the other? Okay. So if they say F below G, it means F is the one that is below, and then G is at the top. But if they had said F of X greater than G of X, then we know who's at the top, F, who's at the bottom, G. So when you are looking from left to right, the interval where that is the case. Okay, because this means f is above g. So you are looking for where f is at the top whilst g is at the bottom. Okay, so that's where if we were looking for questions where f is above, g is below, I mean f is above whilst g is below, then we know f here from negative infinity to negative 3, that's where f is above whilst g is below. So it's x less than negative 3. Here, nowhere. From negative 3 to negative 2, you can see who's on top. It's g, who's below, it's f. You continue from negative 2 to 0, you can see who's at the top, who is below. From 0 to 2, you can see who's at the top, you can see who's below. And well, no answer there. Then, from 2 onwards, in actual fact, the 2, they are equal. They are on each other. Then, after 2, where x is greater than 2, f is at the top, g is at the bottom. So our answers for f of x greater than g of x would be x is less than negative 3 or x is greater than 2. That would be our two answers if the question had said, where is f of x greater than g of x? Okay. So interpreting the question is important. Where is one above the other? That's why I call these questions omunye phezu komunye. What about this? If they say f of x greater than or equal to g of x, that means where is f above g? Okay, meaning he's on top. Also, where is f on g? Meaning where are they both equal or where do they intersect? So you are looking for both where they are, where f is above, but also you are looking for where they are on each other. Yeah. So if you think about it practically, where x is less than negative 3, f is above g, but where they are on each other is at negative 3. So if I wrote the answer for f of x greater than or equal to g of x, I'd say x is less than negative 3. That's where f of x is greater than g of x. In other words, f is above g, where x is less than negative 3. It is on g of x. F is equal to g of x exactly at negative 3. So I would say as well as equal. So x is less than or equal to negative 3. That's where the function f is above g, but also on g. It is where x is less than negative 3, that's where the function of f is above g. But where x is equal to negative 3, that's where the function is on g. So above and on. Above, on. Where are we above? It's where x is less than negative 3. Where are we on? It's where x is equal to negative 3. Where are we above? F, which is this function, is above that one, where x is less than negative 3. That's where the function is above. F is above g, where x is less than negative 3. Where is it on? It is on, f is on g, there, where x is equal to negative 3. So that's why we put an equal sign as well. Okay. Then, from negative 3 to negative 2, g is the one that's on top. From negative 2 to 0, g is the one that's above. From 0 to 2, g is the one that's above f. At 2, we are on each other. Okay. Then after 2, meaning where x is greater than 2, f is the one that is above g. Because here's g, here's f. F is on top, g is at the bottom. So we would say, or where x is greater than or equal to 2. That would satisfy that function. Okay. I don't know if you guys are really hearing this well. So guys, thank you so much. That's pretty much what I have for you today. I want to leave it here, and then I will pick up tomorrow morning. Same thing. Continuing our battle against functions. The battle is not won until it's won. Thank you so much for 23.1k likes for the live, much appreciated, and thank you for all those that followed the live creator whilst we were busy with the session. Thank you so much, and thank you to all my beautiful gifters. Thank you so much for the support. It's much appreciated. Yeah, yeah, yeah. 6 a.m. guys. 6. This gives me a bit of time to sleep in. 6. Yes, you did. But I'll download, I'll end the lesson, download, and then upload, and then send you the link to the lesson. Okay, cheers. Yeah, I am so fluish. Yeah, guys, and don't, like I said, all grade 10s and 11s that were here that would like to be part of my private group that is paid, please, guys, let me know so that I can actually we can make some arrangements. And any grade 9s that are basically wanting to do pure maths next year but just want to end the year in a bang so that they can secure their places in the pure maths arena whilst knowing the basics very well, doing very well. And yeah, please let me know as well. Send me a DM. Okay.